Hey everyone, this is Ed from Barnabas Robotics. Welcome to the first video of our new video series on the Barnabas robot arm. So I have my robot parts here. What I'm going to do in this video is begin the process of building the robot arm and also doing a little bit of coding. So a little note on this video series, it's going to be a little bit different from the instructions that you see online. The ones online, the instructions start with just building the entire arm, and then after that, adding code to it. That's a perfectly fine way to do the whole process. But I was thinking in this series, it might be better for us to build a little bit, add a little bit of code, build more, add a little bit of code, and keep building on from there. I think the benefit is that we're going to understand each part of the robot arm and how it works and how it needs to move as we build it, rather than trying to figure it all out towards the end. Okay, so just a little note on that. And today specifically, we're going to start on the base of the motor. So let's go ahead and get started. So the first thing you need to do is get your wood robot parts. You're going to have 4 different wood panels here. We're going to start with this one right here. So this is going to be the robot base, this bigger piece, and then this piece that will come out will be part of what we call the base motor assembly. So I'm going to just go ahead, you can just remove this tape here. Alright. Quickly, this is just to kind of hold it in place here. Okay. There we go. Coming off. There we go. Okay. So this we're going to be using in a second. I'm going to put it to the side. These I don't need for now, so I'm going to move this to this side as well. And then I want to bring your attention to this one right here. All right. So this is going to be part of what we call the base motor assembly. And what's missing is a motor. So let's go ahead and grab one of these. This is a servo motor. We're going to talk a little bit more about this after we build. So let's take this. And what we want to do is go ahead and take this, and you'll see that it slides in. This is a servo motor. The top of the servo motor is right here. It will slide in like so. And one thing I want to keep in mind here is that we want the white part, which is the motor shaft. That's what turns. We want it to be as close as possible to the center. So you see right now it's at the center or close to it. If you turn it this way, it is offset. We don't want that. Okay, so let's put it towards the center. So that's how we want it, but how is this gonna stay in place? This is where we need another piece. So I'm gonna just set this here for now, because we're gonna have to fasten it somehow. So there's another piece. If we look in one of these 3 panels here that we put to the side, not this one, not this one, but this one here, okay? I'm gonna turn it around this way. So if you look here, we have these different pieces here. You can see that this one fits a motor, this one fits a motor, this one as well. These we're going to use later. The one we want is this guy right here, okay? So let's go ahead and pop it out. So I like to just, you know what, you can just kind of poke your finger here in the back a little bit and kind of pop up, and you should be able to just pull it out. Perfect. Okay. I'll put this back here. All right. So now this is here. Now what we have here is that this will then slide through. Okay, just gonna go behind here like this, and you see there's a little notch right here. This notch is actually to match up with this cable here. So notch to the cable side, and then it slides in. There we go. Okay. So now this is how it looks. Now what we have to do is fasten this little piece here to this bigger piece here, and we should have it work. Okay, they should fasten together. So what we need now is to look at this bag of screws, and it's like, okay, a lot of screws. Which one do we use? Well, there are a bunch of screws. The one that we need is called M3 by 10. So we need it's a 10 millimeter screw. So I'm just gonna go ahead and dump these out here. Okay. And even without measuring, I should be able to figure out here. So this, see if we kind of stick it through here, and kind of look at it, even just looking at it, it's not big enough. So that's smaller. Let's see, probably gonna be this one here. That's my guess. Okay, so I'm gonna get 2 of these. So again, this one's the smallest one here. That's a small one. That one's too small. There's this one. So let's see. There's also this one. Actually, let's do this. Let's kind of line them up here, and then we can kind of see. So there's this big one. There's kind of a medium one, and then there's a really small one. Okay, 3 different sizes. Let's see if there's a different size. Okay, there's this really long one here. Let's see what else we got here. And that may be it. Okay, I'm kind of walking you through this. Be good for us to kind of like check out all the sizes too. Alright, I think that's the same size here. Okay. So I'm kind of winging this because I like to kind of go through the process with you rather than just saying do this, do this, do this, right? So let's say we open this bag of screws and we say, all right, which one is the one? Okay, so we know that the small one is not the one. We could put it to the side though, because now we know there's a super small one, right? There's this kind of second to smallest. Let's see how that goes. This one could work. It should go from this side here, from the motor, okay? So the back of the motor here, we're gonna put it through, and then what's nice is you have this Allen wrench here that can help you easily just screw it in like that, okay? So I'm gonna screw it in. It seems like it's pretty good. Okay, it's going. And you want it to go through, and it does go through. Cool. So I think that's the right one. So let's go ahead and grab another one. All right, here we go. Another one here, and that will go on this other hole. Now, as I'm doing this, so a little note here: as we tighten, we don't want to tighten too much. You just want it snug, so that the motor doesn't wiggle around, okay? If you do it too tight, I mean, this wood here is pretty strong, but it's also wood, okay? So if you go super tight, you could crack the wood, and that would be kind of sad, right? So we don't need to do that. So I just tighten it, I wiggle it. Actually, it's kind of wiggly to me, so I'm just gonna go a little bit tighter. Okay, maybe this side too. And no longer wiggly. Cool. Okay, so I figured out I have some good screws here in, and so this is called my base motor assembly. So this will attach to something else in a second. So I'm going to put this to the side. The next thing we want to do is actually build the base of our robot arm. All right. So now what we need to do is move these to the side here. This thing, okay, now this was where this little guy was in here before. So this thing is going to be the base of our robot arm, all right? Now this part, we need to use that long screw. The longest one, that was this guy right here, all right? For those who want to know, it should be 30 millimeters, okay, in terms of length. So let's go ahead and stick these through. We have 1, 2, 3, and 4, so we stick it through like this. from the bottom. Okay. And it should be 4 of these. So here's my second one. Okay. And let's keep looking. Here's another one, 3. And they're falling out. They're all falling out. Because we're missing something. We need a nut. The nut will go from the top here all the way down here. Okay, to fasten it so that it doesn't fall out. All right, so now let's go ahead and look at all our parts here again. And you're gonna see, now there's 2 types of nuts here, okay? One of them here, it's called nylon lock nut. This one has like kind of this purplish kind of plastic ring inside. All right, that helps it to kind of lock in. And so there are going to be parts of the robot arm that require that to help make sure joints don't fall apart. The nylon lock nut, we don't need that one. Okay, we just need a regular one. So here's an example of one. It doesn't have the plastic little ring in there. So let's get one of these and let's try again. And this time we'll fit it on here, and I'm just going to use my finger. Okay, I can hold it, put one finger down here too, and then just spin it. Spin, spin, spin until it goes there. Kind of like that. Okay, I'm not going to tighten it all the way. We're going to tighten it a little bit later, okay? Because we want it to wiggle a little bit, because when you put this part on, we want to be able to kind of position it. Okay, so if it's really rigid later, it's kind of hard. All right, so that's good. All right, now let's do all 4. All right, so you get another one. Now this time, because I have the nut there, our little bolt, or our long bolt actually, is not going to fall off. Okay. That's good. Let's clear the space a little bit here. Okay, and then we have another one. There we go. And then one more. And then we'll have 4. Right here. And then we have a 4th one. Okay. Here we go. So we have all 4 in. Again, kind of loose. That's good. All right. So now that we have that, we now want to take this part, okay, and this, and let me kind of show you the side view as well. This will go into here, okay? Now, as we do this, we want to make sure that the holes line up perfectly. All right. Now, here's a tricky thing. It will seem that it can go like any way, right? You might say, okay, is it this? Is it like this? Okay, you can tell. Okay, so I have right now, they're all facing up, okay? So they're as flat as possible. They're on the table. If you put it on like this, you see, if you can notice that these two are kind of matched up, but then look over here on my bottom right, this one's not matched up. So if you're not careful, and I've done this in the past because, I'm kind of, in a rush or something, this, you can kind of force it, and then you're going to have issues. You can actually break this piece. So you want to keep turning it when this is kind of flat. So this is flat on the table, right? You want to get it so that it matches. Oh, so this seems good to me. There we go. Okay. So this seems like this is what it's supposed to be. So don't try to force it, right? You're trying to get it there. Just it should sit on there without you trying to like bend the screws too much and everything. It should just line up. So once it's lined up, now what we can do is on the back here, we want to screw these in, okay? As you screw it in, it's going to self-tap, meaning that the screw up here is just going to eat into the wood up here and then help it be stable. So you're going to just get any Phillips head screwdriver, and then we just righty-tighty screw it in. Okay, and you see on the top here, you don't need it to come through as long as it's kind of flush, like smooth. The top of that screw is just kind of is flush or smooth to the rest of the wood up here. We're good. Okay. Same here. And you just keep doing it all the way around. There. Okay. Nice and flush. And then this one here. Good. Okay. And then this one's here. Now as I'm doing this, another note here, okay. If you find yourself trying to align it and it just seems one of these screws here are like totally crooked, like trying to bend, you're trying to force it to line up with the hole as you're turning down here, that means this is not aligned correctly, and you should, just check it out and maybe probably turn this until you don't have these screws slanted. Okay, so it should just be smooth when you're doing this. All right, if it's not smooth, that means that your top here needs to be rotated. All right, and another note is that it might not look exactly like mine because the way that the board is designed, there are kind of more than one ways that this thing can come together. Okay, just keep that in mind. The key thing is that these things need to be smoothly just aligned. All right, so now that once you have that, what you can do is tighten these down here, the nuts here that are kind of smooth or kind of loose. I just like to do it with my finger. Just go ahead and tighten it so that it goes down to the board. Okay, tighten. There we go. This one as well. And then this one as well. There we go. Okay. Now if I look at my robot here, I have my base motor on, okay? And it looks like everything is looking good. Cool. Okay, so now what I want to do is I want to go ahead and wire this thing up to something. All right. So now let's take out this guy. So this is our Uno, our Arduino board, which is gonna control our motor here. Now before we do that, before we plug that in, we need this. Okay, this is a shield. And so a shield is something that goes on top of the Arduino that gives you some extra features. All right, these things are going to be used to control. These are dials here called potentiometers. You're going to be able to control the motors and things, but we're not going to worry about that today quite yet. Okay. All right. So let's go ahead and stick this on. You'll see these. There are these spikes here. Okay. These spikes will match up with these receptacles down here. Okay, these black ones right here. So let's go ahead and do that. And so we just match it up. There's only one way that it will go, where every spike will match up with one of the black holes here, the receptacles. And we call those pin headers. Okay, these are pins here. The spikes are pins, and then these are pin headers, the black receptacles down here. All right, let's stick it in. This is the way, and it should match up. See? Boom. And this side too. Boom. And it should look like this. Okay? Cool. Cool. So now that we've done that, we can take this and we're going to stick it into Servo 4. Now you might be asking, why are we not doing Servo 1? The reason is that we've decided in the curriculum to wire it a certain way, so I want to in the instructions online, so I want to keep it consistent with that. Okay, so you're going to see Servo 1, 2, 3, and 4. We're going to stick in the Servo 4, and brown's going to be facing on the inside. All right, so we go Servo 4, and then the brown wire is going to be facing on the inside like that. There we go. So we're wired up. Okay. The next thing we're going to do before we start coding is we're going to take this inside the servo motor bag. We're just going to take a servo horn. That's one of these right here. Let's go ahead and take this one right here. Let's just pop it on top there. Okay. You don't need to screw it in or anything quite yet. We just want to pop it up on top. And once you do that, you can kind of turn softly and kind of see that it rotates. All right. Another note, when we do that, don't push down too hard. If you push down super hard, this here could break. All right. So again, it's wood, it's strong, but it's not like super strong, right? It's not like incredibly strong. Okay. All right. So now let's see if we can get this thing to work. All right, I'm gonna change my screen now to be, oh, actually before that, let's take our wire here, cable, one side in here, and the other side is gonna go into your computer. Okay. There we go. I'll just leave that there like this. All right. So here's my code here. And let's go ahead and write some code. All right. So I'm going to just give a quick refresher. I know that some of this, you may know this already, but I just want to make sure that everyone is on the same page here. So this is Arduino code. The type of code, the language that we're going to be writing is in C, which is the base language for Arduino. All right. So we're going to create two functions, void setup. That's one function there, and void loop. Okay. And what are these two functions? Well, void setup, I'm putting a comment here. This slash here is it turns green, meaning it's just a note. It's a comment. It's not actually going to be run by the Arduino. So it's just a note for us saying that setup runs only once when you turn on. And then loop runs forever in a loop after setup. Okay, so when you first turn it on, setup runs, and then after that, the loop runs. Right now, it doesn't have anything inside setup or loop, so it's just going to do nothing. But once I have these two base functions we call setup, let's go ahead and do an upload. I know nothing's going to happen, but I just want to upload to make sure that my computer is talking to my Arduino here. All right, so let's do this. Now as we do this, we want to make sure that the board is Uno. Okay, and lesson, it doesn't matter. That's for for the block mode, where we're in text mode. Oh, and then also make sure it says block code here. Okay, if it doesn't, it's gonna say, I'm just gonna copy this because it might be gone. Okay. Click OK. If your screen looks like this, then you gotta click here, text code, to go to the text mode. All right. So we're on the text mode here, and let's upload. Click upload. Okay. Select your device here. You gotta select it. And make sure it's connected in USB. If it's not connected by USB, you won't see this option here. Click connect. And we get this green circle. Cool. Okay, that means we just sent this code over. We get the green circle. We're good to go. Okay, so let's do this first thing. Let's try to get this motor here to turn. Okay. How do we do that? Well, this is a servo motor, so we need to include the servo motor library. So I go to hashtag include. I guess that's a less than sign, servo.h, and then a greater than sign. All right, so that's a servo library. All this is saying is I need to know how to move my servos, so I need to get the servo library, which is basically a bunch of commands. Okay, just think of any library, like the library at school. It's got a bunch of books and things like that. So the servo has the servo library is basically the bunch of information or books that teaches you how to move the servo. All right, so we want to use that in our code here. So we need to include servo.h. Now let's create a servo object. So I'm going to say servo. Okay, that's saying I want to create a servo object. So just think of every time that we have a motor here, it's going to be a servo object. So we only have one motor right now, so we're just going to have one servo object. Okay, so I'm going to say servo, meaning I'm going to create a servo object, and I'm going to call it base motor. All right, and I'm using the camel case here. Again, this might be repeat for some people. I just want to make sure that we're all on the same page. Camel case is just, it's a way that coders write where the first letter is going to be lowercase, and then the first letter of the subsequent words are going to be uppercase. All right, it's just a way to get two or more words like in the same without spaces, but making it readable at the same time. All right, so we got the camel case base motor, and now let's set it up. All right, so we have a base motor object. It's going to be this one right here, and we're going to say base motor in the setup dot attach. I'm going to put a number in here. Now, what number is it? So I put it into the number 4 pin. Now, you wouldn't necessarily know this, but I know this. Even though it says servo 4 on our little board here, it's actually going to be pin number 6, okay? Don't ask me why. It's the way it is, okay? So it's just pin, and you wouldn't know that. I know that because I know the design of this board here. So when we connect our motor here to servo number 4, it's actually pin number 6 when we do code. Okay, base motor dot attach 6, and then I'm going to do a semicolon. And I'm going a little bit fast, I realize, because I didn't tell you about the semicolon thing. All right, when you make a statement, basically a sentence, you're saying, I want to do this, and then you want to end that sentence. In English, you use a period. In the language of C, you're going to be using a semicolon. Okay, so that's why we have a semicolon there, we have a semicolon there. Cool. Now, let's try this. All right. So now that we've set up our base motor, so this is our base motor, and we said, hey, I want you to attach pin number 6 to this base motor, so that whenever I move pin number 6, it's gonna move the motor. All right, that's what this line of code is on line 7. Now let's actually move it. So I'm gonna say base motor dot write 0. Okay. Now a little bit about servo motors. So servo motors move half a circle, all right? It can go, which is 0 to 180 degrees. So I'll just put a little note here. Servos move half a circle, 0 to 180 degrees, all right? So that means the smallest number you can move to, the smallest degree is 0, and the largest degree is 180. All right, so I'm gonna just start at 0 and see if this thing moves. Okay, let's try running this and see what happens. Okay, you saw that it moved. Okay, and then now if I say, let's say 90, because that could work too. Let's see, it should move again. Send my code over. Okay. And then 180, because that's the maximum, should also work. Okay, that also works. Okay, so it kind of moved across the whole range from 0 to 180. Now, there is something I want to try here, okay? So I can't really tell. It's not easy to tell. I'm going to change to the larger screen here. It's not easy to tell where it's pointing because it has like two big pointers here. So actually, let's change this. If this is the one you have on there, let's take this off. And let's go back in our bag here and let's get the one that only has one wing. This one here. All right, let's put this one on there. And then let's also turn our robot arm so that it's turned the way that it's supposed to be. All right, because what's going to happen is that this is going to be here, okay? And then the robot will be here, and I'll use my screwdriver as an example. All right, so the robot should be able to go like this to down here. It's like rotate up this way to down here. So now what we're going to do is what's called calibration. Okay, so we're going to put this just randomly just onto there. Okay, and we want to make sure that however we have this on here, we want to make sure we're going to move the full range of 0, let's say 0 to 180 degrees. So let's try that out. The way I like to do it is this. So let's go ahead and go to angle 0. So I'm going to change that to angle 0. Okay, so it says 0, and then you can see that it moved up there. Okay, again, yours might be a little bit different, all right, because there are more than one way to put this robot arm together, all right? But my 0 is pointing up, so that's cool. That means if I want to go all the way to this side, it should be 180, which I think it was because I was looking at it earlier. So let's go. If I change it to 180, and go upload. It goes down that way. Cool. So I like it like that. Now if I wanted to go in the middle here, then I just put 90 in. You can look up there on the top right, and it goes to 90. Perfect. Okay, so now that I have it oriented the right way and calibrated, and just so like you know, because mine actually was pretty good. I'm just gonna mess it up, okay, to show you how you would fix that. All right. So let's say yours is not like that. I'm just gonna go like this and just put it like some random spot like this. Okay. Like there. Okay. So that's, and then let's go to 0. Okay, so if you look at the pointing, that's not what I want. I want my 0 should be pointing up, okay? So then, but I know that my code is at 0. See, my code is at 0, right? It's saying going to 0. So all I do now, because this is not fastened in, I just kind of cheat. I just take that off and say, well, it's pointing at 0 in the code, so then I just move the arm to where it should be at 0. And then I'm calibrated. Okay, so now it's all set up. So that's the easiest way to do it. First, write the code to go to angle 0, and then put your robot arm, the servo wing at this point. It's not really a robot arm where you need it to be, and then you're set. And so I'll prove it to you, because now if I go to 90, it will be going straight down the middle. Cool. So now let's do something a little bit interesting. All right. So let's say I want to go from 0 to 180, and I want to kind of move back and forth. How do I do that? Well, I just go here. I'm gonna go to 0 first, and I'm gonna put base motor dot right to 180. So it's gonna go to 0 and then 180. Okay, so that's pretty good, but I also have to add a delay. And the delay is there because the code processes really, really quickly. So if I just go 0 and I have no delay, it's gonna say 0 and then right away to 180. So before it even gets to 0, it's gonna try to do the 180. So you won't be able to see it. So that's why you have to put this delay to say, okay, go to angle 0, chill out for 1000 milliseconds. That's what this is, which is the same as 1 second, and then go to 180, and I'll put a delay here, chill out here. Okay, so let's go ahead and run this. Cool. So that worked. But now I want it to go in a loop. How do I do that? Well, based on what we learned before, we just take this. Remember, setup only runs once when you turn on. But if I take this stuff, my code here, I'm going to cut it. Put it there. It's going to run in a loop forever. Let's go ahead and upload this. Cool. All right. So, I think that's a great start. So why don't we have a few challenges here? I'm going to disconnect here so my motor stops. But a few things you can play with, all right? So let's go with challenges here. I'm going to make what's called a block comment. So everything in between here and here is going to be a comment. So challenge 1 is going to be calibrate your one-winged servo horn. Okay, that's this white piece here, and that's what we just did, where we put 0 first and then we put it pointing up. Now again, if yours is flipped from, you might have it flipped from mine. I'm not totally sure, but as long as you have 0 is either up or down, that's okay. All right. So 0 can be either be up or down. All right, just make sure it's not some weird angle or something like that. Okay, it needs to be up, north, or south. All right. Then challenge number 2, something we did already. Make it go back and forth between 0 and 180. Okay, that's something we did here already with putting it here. All right, and just adding a little bit more complexity. Move it between 0, 90, and 180. So when you do that, it should go to 3 different spots. 0, 90, 180. 0, 90, 180. Okay, like rotating. Okay, challenge number 4, move it like 0, 90, 180, 90, 0. So it would go 0, if you can see, look at me on the bottom right there. So 0, 90, 180, and then back to the middle 90, and then back to 0. Okay, so kind of like a clock. All right? 0, 90, 180, 90, 0. Okay. Number 5. Move it like 0, 45, 90, 135, 180. I'm just going to keep going here. 135 to 90 to 45 to 0. Okay, there's a lot of numbers there. But basically what that is making it move a little bit more like a clock because you're having more stops. But it's going to just kind of sweep from 0 and sweep like all the way down and then all the way back. All right. And then challenge number 6. This is like the next level here. I want you to move it as close as possible to 30 seconds on a clock. Okay, so what does that mean? So on a clock, on a traditional clock, and I'll kind of draw it here. So a traditional clock looks like this, okay? Let me do a better circle. Okay, where you have 12, 6, and 3, 1, 2, 4, and 5, okay? Now, because our servo motor can only move half a circle, I'm going to say, you know, forget about the other half of the clock, okay? Forget about that part. And so what I'll do is, let's just erase it, okay? Okay. Now, there's a second hand, right? So the second hand will tick like this, 1 second, tick, 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 and there'll be 30 ticks to get to the 6, okay? And then total time equals 30 seconds, okay? Because on a clock, the second hand will take 30 seconds to get to here. So try to get your little servo motor to move just like this. So it's to start at the beginning, and then by the time it gets to the end, it should take about 30 seconds. Okay, just a little challenge. You might need to do a little math there and then a bunch of code, but I think it's a good challenge to kind of get comfortable with the servo motor. All right, so that's all we have for today. So we have that set up. In the next video, we're going to build the next part of the robot arm that will go on top of this piece here. But by then you'll be totally comfortable with how this is wired and how that servo motor moves and everything, and we'll have to calibrate it, but you already know how to calibrate it because we did it here. All right, have fun with that. If you have questions, let me know. Take care.